Working on this problem, we have a system of equations. Since both of them are equal to y, I can set them equal to each other. So I'm going to get x squared plus 2x plus 5 equals 2x squared plus 4x plus 7. Since this is a quadratic that I'm solving, because my highest power is 2, I'm going to go through and solve it using one of my solutions for quadratics. What I need to do first of all is set it up equal to 0. So I'm going to move everything here to the other side. That's going to give me 0 equals x squared plus 2x, because I'm subtracting this 2x from both sides, plus 2, because I'm subtracting the 5 away. From here I can do the quadratic equation. My a value here is 1, my b value is a positive 2, and my c value is 2. So, x equals the opposite of b, plus or minus the square root of b squared, so that's 2 squared, minus 4 times a times c. So 4 times 1 times 2 is going to be 8. And then everything is divided by 2 times a. That is going to simplify down to negative 2 plus or minus square root of negative 4 over 2. You can see that I have a negative number underneath the radical, which is going to give me complex roots. So simplifying this again, I have negative 2 plus or minus 2i over 2, which then, from there, I can divide everything by 2, and I'm going to get the answer of x equals negative 1 plus or minus I. Now, since this is a system of equations, I've solved for x, and I have 2 solutions. Now I need to plug it back in and solve for y. So now I have y equals, and one of my solutions was negative 1 plus I squared plus 2 times negative 1 plus I plus 5. Maybe a generic rectangle would help out to solve that. And when I do multiply it out, I end up getting 1, positive 1, minus 2i minus 1. Because the box in my generic rectangle will be I squared, which is negative 1. Distributing the 2, I will get negative 2 plus 2i, and then I have plus 5. Combining like terms, negative 2i and positive 2i are going to end up equaling 0, so those will cancel each other out. I also then have a positive 1, a negative 1, which will cancel each other out, and then I have a negative 2 and a positive 5. So this equals 3. Substituting my other value for x in, so y equals negative 1 minus I squared plus 2 times negative 1 minus I plus 5. So this is the other value of x that I solve for. Again, using a generic rectangle and simplifying. 1 plus 2i minus 1. Distributing the 2, I get a negative 2 minus 2i, and then plus 5. Same as before, I have a positive 2i and a negative 2i, which will cancel each other out, make 0. I have a positive 1 and a negative 1, which will reduce down to 0. And once again, a negative 2 and a positive 5, which means this also equals 3. So I now have two different points where these parabolas will intersect. One of them is going to be negative 1 plus I, comma 3, and the other one will be negative 1 minus I, comma 3.